Hey guys, welcome back to the channel. I have a interesting case here. This is a 2003 Dodge Ram 3500 with a 5.9 little diesel engine. I think this is a Cummins engine. This one sent to me from New Jersey. Ira, this is your computer. The last digits of the VIN number, even though the computer, this computer will not auto ID, so I have to select the computer or enter the VIN number, and then that will work. But yeah, this is just so I show the VIN number in here, last digit A016111. And as you can see, I have multiple pits selected because his concern is the supply voltage for the Bistronic fan drive. So this one uses a fan speed control. It's a pulse width modulated signal, and then it has a sensor ground and a sensor signal. He said that when he's checking this, he has found, let me just read his actual, let me just make sure I can cover this 1 sec. All right, I got that so we can all read it. It says that he has code P0111, P022509, and all those that you see there, codes, clear codes during testing, and P0107 and 642 and 483 come back. I have not even checked what those are. He said they scope all 5 volt powers to sensors, and the only one that is dropping out, it is the supply to the fan speed sensor. Tested, power and grounds, voltage drop, loaded and unloaded to the ECM, all tested as good. 5 volt sensor supply problem circuit is pin 23 and connector C2. Unplug fan assembly and 5 volts still drops out. I don't see that here, so something else is dropping the 5 volts on this one. So this is what he's sending me. Connector 2 on the computer is the one where I am actually connected. So we got connector 2 and connector 1. I got all that information pulled. So let me just make sure I am not showing any other customers information. So let me just pull those here. So yeah, connector 1 is a 60 pin and connector 2 is a 50 pin. All right, so again, this is connector 1 with 60 pins and connector 2 with 50. If we go over to pin 23, it says 5 volt supply. It's a a normal supply of 5 volts, and we got other ones. So I have gathered a lot of information on these modules, and I have mapped out most of the voltage rails and connectors. So when I'm looking at the computer from the top, like this inside, I know exactly what I'm looking at, and those again, those are all mine captures of my information. But yeah, so pin 23, we have another 5 volt reference and 33. And we also have, if we move this up, so this is connector 2 in the same sorry, let me just see. No, it's connector 2. We only have 2 5 volt reference and 23 and 24 and sensor ground right next to it, which is very important. And we will check that in a second. And then we have more in here. So all these are grounds, sensor. Well, actually, yeah, I think that's sensor power, sensor power, sensor power. Because if we go over to what I did in here, so 54, I put them on separate and a little bigger because that's a cam position sensor 5 volt reference. But all the one that has a star with a number are 5 volt reference. All the stars with a number are sensor grounds. Even though this 32 says capture position sensor ground, this was for another computer that I market, but all those are same grounds. So what I want to do is I have the oscilloscope connected. I have this computer connected for probably 2 hours. I apply heat to the computer, try to make sure that we are not losing anything, and we are not. So I'm going to put a cursor right here on 5 volt reference around there, right? So around 5 volts around there. Right now, the yellow lead is not connected to anything, so it should be in 0 volts, and it is. I am using an attenuated 20 to 1 just to make sure that I don't disturb the computer. This is a way to protect the computer so no noise is injected to the actual module, especially since I'm going to touch the fiber reference. I can see voltage is very steady. I don't see drops or anything. We can go over to these ones and we can graph it. So let me actually, I think, let me just see 1 second. Let me go into graph. And then I can combine the graph. So we can only have a maximum of 4, so that's perfect. So we don't need the battery voltage. We don't need the pulse width. So let's just get the ones that we can see, 5-volt reference. And as we can see, they're nice and steady. There is no drops. The scanner is not showing any drops. And these are 5-volt reference. They're all 5-volt reference. So no drops in there. I'm going to, to check pin 23 with you guys. So let me do a split screen so I can see exactly, and you can see exactly what I'm doing, and then the result on the yellow lead or yellow channel. The other channels that I have in there are, as it says on the bottom in here. Let me erase what it says in here because this was for another test that I was doing. So this should not be anything in here. It's just whatever I'm touching. But yeah, so we got in the blue channel, we got DLC7, the red channel is DLC12, and the green channel is DLC2. When you connect this to this computer without a scanner, if you are just connected to the DLC port and pin 2, you should have that, the green channel. Blue and red will not come on unless you have a scanner connected and it's talking. Like let's say, when you start to get communication, you will have some like package of data in there. They'll go 5 volts to 0. And let me show that because I think it's important to share all this. So let me do a zoom in here so we can see all this. So if I measure the blue channel so you guys can see what is reading with communication. And we can do the same thing on the red channel. So it's a 5-volt reference pulled to ground, one by the microprocessor and another one by another IC inside. And it's like three different ICs in the circuit of the DLC2, DLC7, and DLC12, which is what is this computer needs in order to establish communication. So, yep. So that's what we got in there. So let me now remove the zoom. Oh, I forgot to measure the actual, let me get all this out. Pin 2, right? So pin 2 is really, so it's pulling up from 0 to 7 volts, we can say that. So that's DLC2. And we can see all the packages of communication. Everything is nice and clean. I can reduce the speed again for what I was doing. I was just put them in there for that speed. But yeah, as you can see, it's nice and square. I got a small filter of like 50 kilohertz just to clean the signal, but everything is looking good. All right, so let's go over to that sensor power. So I'm going to touch into pin 23. Let me just make sure. So pin 23, if I'm looking this from the tap connector to this side, it will be the third row, the third pin. So third row, third pin is this one right here. And I forgot to put the cursor, so we don't know what we're reading. So I'm going just to put a cursor around 5 volts so we can see that that is a steady 5 volts. And that is his concern, specifically on pin 23. So third row, third pin. And we can see that 5-volt reference is 9 steady. I mean, nothing, no breaking, no glitches, no nothing. I'm not sure exactly what is he's seeing on the vehicle. I'm going to move it over to the third on the 4, which is pin 33, another 5-volt reference, and we can see that that is an image. These 5-volt references are internally interconnected. This computer uses only one 5-volt reference. And that's all I can see. Yes, there is another 5-volt reference for the camshaft and crankshaft position sensor only. But for the rest, I have not seen that. So let's now measure pin 24. So that will be third row 4 pin to see how that ground looks. And that ground is nice and clean. There's nothing wrong with it. And I can touch, and I did already measure, using the multimeter, which you can do is touch pin 24 and 23 with your multimeter, and it should read 5 volts steady. You can do that the same thing using your oscilloscope with 2 channels, let's say, and you can touch both, and you will see, or using the same channel, right, like negative and positive. I mean, be careful which oscilloscope you're using to make sure that you're not shorting the ground. If you say that backwards, these are not floating grounds, not on this one. And the 4425, you got floating grounds. So each channel is a completely separate circuit. In this one, all grounds are shared. So I have to always be careful that when I'm using a ground, is a ground. In the other one, all you will have is a reverse polarity, let's say on the 4425, but not in this one. But yeah, I cannot seem to find anything wrong with this computer, Ira. I cleaned the computer because it was so dirty. I have to put this on my bench, and I put a special chemical to clean it. I please, if you're going to send a computer to the lab, I will please request that you send computers, and this is for everybody right now for Ira, but yeah, for everybody, if you're going to send a computer, clean it, no dirt, no grease, no oil, because this is electronic components. And I take the time to clean it, but if I have to do that, then uh, I might have to think on maybe adding a charge or something. This wasn't so bad. I got another one in here. As you can see, I got another board exactly. This is a 2004. That is a 2003. That this was just mud and oil and everything. I have to clean it too as well. And let me show you how that comes out. This one it has a cover of like a some sort of a clear coat or something. But yeah, it's now nice and clean. This one has no communication, and I have to work on this one. But yeah, so Ira, again, I don't see any drops, any problems on your computer. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.